Okay, I'm Ethel from the University of Glasgow and doing my PhD there with Quentin Katz. And my topic is on understanding conceptual transfer when students are learning new programming languages. So, well, I have the outline there. But why am I particularly interested in this topic is that a lot of research papers out there are talking about transition problems from one programming language to the other. We have lots of them talking about blocks to text based language transfer difficulties, as well as between text based language transition difficulties. And we've had lecturers in corridors, they can just say, I wish they didn't bring any prior knowledge because now teaching them is becoming more difficult and complicated. So as much as these problems are reported, I haven't seen a model or or something that will try to explain why we are having all these transition problems. You know, the cognitive activities that they go through and why some concepts are easier to transfer than others. So I looked at the existing transfer studies in computer science education research, and we have lots of studies that talk about misconceptions, and most of those misconceptions are based on the transfer from natural languages or mathematics to programming languages. And Paul was just, I think it had something to do with Paul's study who just presented, trying to, you know, explain a variable to student using the box analogy. So it's like you try to transfer the knowledge by using some knowledge that they already have to try to explain a programming concept. So and then there were other transfer studies that were mostly based on experienced programmers, and they were testing the problem solving, how programmers are transferring the algorithmic skill or the plan transfer from one programming language to the other. So Rina was presenting earlier on about computational thinking, which she links to problem solving in learning, in teaching programming. We have the problem solving part of it. Some might call it computational thinking, and then we have the code comprehension part, which is like it's a recent line of thinking. Um, you will find lots of that. Even School talks has a model that explains how programmers understand code. So I found that we don't have existing studies on which are based on code comprehension and conceptual transfer. Or we can say if someone has already learned one programming language, how do they transfer the conceptual knowledge, or rather the semantic knowledge? Is everything okay? Hello?
Yes, I can still hear you. I
Yes,
think
it's
there's just a
fine.
brief
How
blip.
do they? Okay. So how does one transfer the understanding to the next programming language? Because we should be expecting some kind of transfer to happen and to even benefit the way we are teaching programming as students are upgrading or going to the next levels of education. So we're gonna do just a simple activity. Don't answer me, just think about it. This one is just trying to explain the idea of how natural languages research explain transfer. So when you look at the word la music, which is a French word. I'm not sure I'm pronouncing it right, but what do you think it means in English? And then when you look at the word deception, I'm not sure about the pronunciation. What do you think it means in English? So going back to the La Musique, I guess people who don't know French in this group might have guessed it could mean music in English, and they are correct. But then if anybody thought the second one means deception in English, then they are wrong. It actually means disappointment. So we have lots of psychology research that talks about how people understand things based on similarities. So even in natural languages, when people learn, apparently these cross-linguistic similarities by Rimbaud. When people learn new natural languages, sometimes they use their existing knowledge of a language to try to understand the new language they're learning. So what I did was to try to explore the semantic transfer theory uh, from natural languages, to explore how that is relevant to programming languages and understanding, and how paying attention to semantic transfer can help in instruction. So I had a qualitative study with only 5 participants at the university. uh, they were doing second year. They had learned procedural Python, so they had no idea about objects, and they were just starting in their second year to learn object-oriented Java. So the study went on for 11 weeks. I was meeting them individually on 1 hour basis, just talking through Java code and letting them go through it line by line and try to explain what they think it means. And the interesting thing is I started the experiment even before they had started learning Java. So the first week was before. I made sure I get participants who don't know Java. So I started off with, before learning Java, what can happen, what can be the automatic transfer, and then we kept on doing more activities as the weeks went by. We had 2 females and 3 males. So the key findings in that research were that there was some kind of positive transfer for concepts that looked similar to their Python knowledge, like variables. Variables are tricky because the second point I'm gonna make will show that there's some components of variables that they understand easily, but there are some that can be confusing. But if conditionals were very easy for them, methods and parameter parsing. So we would look at a code, a code snippet of a concept, and then they'll say things like, I think this could be a method. That was before they learned Java. So they would say, I think this could be a function. They called it function because I can see there are brackets in there. I can see that. So they what spiked the thinking, the connection, was the things like the tokens, the programming language tokens, things like brackets, the keywords, and the operator signs. So the second one, where now there was negative transfer, is whereby I think it was halfway through the Java course, I asked them about variable assignment, reassigning a variable that was initially assigned to a different value, to a different data type. That was midway in the Java course. And I know some of them were okay with that concept. They were not confused, but some of them, I remember one of them was, I said, talk through, what do you think is happening here when I say int a equals to 1, and then later when I say string a equals to Ethel. And she's like, well, I think obviously A will become Ethel because this looks very similar to Python. It's the only difference is that I can see the type being, the type is written there. So you see that they transfer the knowledge of how dynamic Python is in reassigning variables to their understanding of how that works in Java. In Java, we don't do that. Once you have assigned a variable, you can't reassign it to a different type. And then there was the interesting one of where there was no transfer or minimal transfer, and this had to do with dictionaries. I mean, with objects. Students were already familiar with some kind of data structure from Python, and the one that I would maybe link to objects would be a dictionary. But of course, in Java, we talk of a more abstract, data type where we have a class as an abstract data type, and then we have objects as the data structure in there and methods operating on them. So those concepts were confusing for students. Unless the instructor explains it just remains confusing. So I used the key findings from this qualitative study to come up with a model or a hypothesis of how I think this might things that might be happening when people are learning new programming languages. So it's still the whole idea of the results there, but here we are talking. I had a hypothesis that if the similarity in syntax and semantics, the students will effect positive semantic transfer. If there is similarity in syntax but differences in semantics, negative transfer will happen. And then if there is difference in syntax but similarity in semantics, they might be transfer, but they won't be transfer at all. So what I did to test this hypothesis was to conduct a study with 120 participants who were also transitioning from procedural Python to object-oriented Java. It was a within participant design, so there were no controls. Everyone was exposed to the same treatments within the same class. They were given code comprehension exercises in Java and Python, and those were given in week 3 in the early stages. And then there were some small interventions by the instructor whereby she was explicitly showing similarities and differences between the two languages. And then there was a post quiz in week 9. So there was another study that I did. This one was interesting. It was at a different university, but this one was purely based on guessing. Like they had not learned Java at all, so they were given the same code comprehension exercises to try to write down what they think the answers might be, and the results will follow. It was still a within participant design, but these ones for study 2 they had not learned Java. It was in the beginning, the first lesson. So these are the examples of exercises the students were given. When I talk of similar syntax and similar semantics, I talk of a while loop. You can see the keywords there, the similarity. There is the similarity in the print there, the I variable, although it can be used as a different variable name, but there's similarities there. And you need to know that me as the researcher, I was the one who was deciding what might be similar and what might not be similar, based on my qualitative study of how I saw the students interpreting similarities. So I was,
Ethel,
yeah.
we've got about a minute or a bit to wrap up.
How much?
about a minute and a bit.
Okay.
Stretch to 2 if you like, but not too
Okay.
long.
So the results were very, very similar to the study one results. Um, there were no significant differences in concepts with similar syntax and semantics, and there were significant differences in the other concepts that were a little bit difficult for students. So what does that say to educators? I think this one, I can actually take it on to im- the implications to teaching for transfer from block-based to text-based. It's still similar to the previous slide. So I think in block-based languages, most of the teaching is based on problem solving or computational thinking, designing games and all, but little is the little emphasis is put on the conceptual knowledge, explaining each concept to the students and the semantics. And we can take advantage of automatic transfer by looking at similarities, like the if conditional there. And then students might be confused by things like this, where now we are using operators, there we are using words like join. So we need to be explicit about explaining them. But it would also be more interesting for the designers of the languages to, explore these things and see how they can create, if languages that are more similar to syntaxes that are more similar to the programming languages that are used in education. Yeah, thank you.